Welcome everyone. Still people are joining us for today's webinar. We'll be waiting for another 2 minutes and we will start. Okay, we can start now. Welcome everyone for this month's webinar in Lighthouse Worldwide Solutions. Before we start, let me give you some brief information. First of all, anytime you can use questions chat box to send your questions in. I will not stop and answer questions, but at the end of the webinar, I'm going to answer questions as much as I can. Then after that, if anyone's question will not be answered, make sure we are going to get back to you and we will be answering all these questions through your email. Don't worry, all questions will be answered. And you are going to see the handouts sections. Today we have 2 files for you. One of them is the presentation handout, which we are sharing with you under this handouts section, GAP, how to test HEPA filters webinar handout. And the second one is ScanAir Pro brochure, which is we will describe today as one of instrument for installed filter leakage system tests. My name is Hashim Solmaz, and I'm working in Lighthouse as responsible for EMEA operations. And I'm also serving to ISO TC209, which is responsible to write all these ISO standards for Cleanroom 14644 series. And also I'm serving to working group 3, Cleanroom Test Methods, which is responsible to write ISO 14644-3 test methods, Cleanroom Test Methods. I have different responsibilities in different organizations like IEEPS, and recently I've become one of the IESD Contamination Control Institute faculty, which we are also covering ISO 14644-3 in our IESD training sessions. Today's webinar content, we are going to start with filtration basics, and I'm going to cover standards and international regulations regarding filter testings, both production side and lab testing, as well as on-site filter integrity installed filter system testing. And we are going to see these installed filter integrity testing difference. There are 2 methods described in ISO. One of them is aerosol photometer method, another is the particle counter method. So I'm going to give you a brief information about these 2 methods. First of all, let's start with the filtration basics and its theory. And each filter starts with the filter media. This could be fiberglass media, which is well known, but there are some other advanced technologies like PTFE media, filter media. But these fiberglasses become a pleat filter, then glued to each other, so it will the air will pass through inside it. And the idea behind is to increase the total area of filtration with this pleat method. Then after that, it is mounted inside a structure and mounted into the final locations. And there are non-woven filter media with a lower efficiency level filtration, which we know generally pre-filtration systems. Then they're also framed, so they are protecting your high-level HEPA and ULPA filters with a pre-filtration technique. Main idea behind the efficiency, all the classifications, all filter classifications are based on the efficiency of your filter. So the main idea here is you are sending an aerosol on upstream, which is an inlet side of your filter, and you are collecting all the downstream particles underneath the cleanroom side or the clean area side of the filter. So the ratio between these two as a percentage gives you an efficiency of your filter. But there are different methods to verify this efficiency. I have to say you will hear this more and more today. The efficiency testing is not an on-site installed filter test. Efficiency is what we are doing while we are manufacturing these filters. That's why when the manufacturers are preparing filters, they are making a classification according to standards and regulations, which is EPA, efficient particulate air filters, which is efficiency value is around 85 up to 99.5%. And high efficient filters, we know them as HEPA, high efficiency particulate air filters. They have a lot of nines on it, so do ULPA filters, which means if you have, let's say, 1 million particles on upstream side, you have a couple of hundreds or even less than this on your downstream. So most of these particles will be captured with the filter medium. So increasing HEPA efficiency also increases the classification of your filters. If you take a look at these filter media under microscope, HEPA filters will be pretty much something like this. All the fibers that you are seeing are randomly matched to each other, and then this creates a filtration. When it comes to HEPA, you are going to see more dense fibers pile up on each other in this paper media. And when it's become an ULPA, just an example, a little bit exaggeration as well, but right side we're seeing your hair, on the left side is a pollen, and behind is the fiber media in a ULPA, ultra low penetration air filters fiber media. It is so dense that these filters can easily capture 0.1 micron particles. When it comes to this point, filters are classified with MPPS value. I will come to that later on, which means filters are so much efficient in a smaller sizes, and MPPS value, which we will come later on, will define our filtration efficiency. This is the lowest, our bottleneck for filtration technique. And each filters come into this filter frame, as you can see on your left side. This filter frame would be thicker or wider depending on the filtration volume. So if you want to pass a higher volume of air at the same time, so you have to get a continuous sheet of filter medium into it. So these aluminum separators or any technologies that separates filter paper from each other allows you to pass as much air as you can through these filters. And there are techniques, there are mechanisms which we can describe through this presentation, allows us to filter particles. First one is sieving, straining effect. This is particles which are larger in diameter than the clearance between two fibers cannot pass. This is where the particles is too big to fit between two fibers and is pulled out of the airstream, much like a colander catches noodles. But most of the people think that this is the main mechanism for filtration technology. We are expecting it to have a mesh system, so the particles will not be passing through these mesh. However, only 1% of filtration is going through this mechanism. There are other mechanisms attributed for filtration technology. The second one is inertial separation concept. Inertial separation concept, these large particles have high momentum, which makes it difficult for them to follow airstream around a fiber. We all know that the air is also a fluid, like a water. So think about having a river and you have leaves passing through the river, and if you have a rock in front of them, they will be passing around the rock. But if you have a log, the big log, it will go directly to the rock and will hit directly to rock, or even captured by the rock, because it won't be able to pass around it. So this is exactly the same mechanism that we are using for filtration. And the next mechanism is interception concept. In this concept, small particles follow the airflow around the fiber and are captured if they come close enough to the fiber. In order to understand this concept, one needs to be aware of how intermediate and small particles interact with these fiber media. This is also known as van der Waals law, and these particles will be picked up by this method, and they are going to stick around the filter media, not in one side, not directly from the air side, but also around it. And another method is the diffusion concept, which is also known as a Brownian molecular motion. This is a diffusion in the wavelength direction of filter fibers, can be found only in the case of very small particles, such as viruses. All of them are captured with this because it's a molecular level of motion, and they will not be able to follow the mainstream of air, so they end up attaching into the surface of filters. This is one of the highest filtration mechanism that we are using for filters. Electrostatic attraction concept, as you can see in the video again, and in this video, the positive pole is going through the material, so the negative force, which is directly comes through the particles, are attached to the filter media. So this is called electrostatic attraction concept. When we look at all of them together, now we can define MPPS value, which is most penetrating particle size. Let me describe it with my laser pointer. Okay, the first method we used was the diffusion and electrostatic method, which is mainly active below 0.2 micron and goes up to 100% efficiency for the lowest possible particle sizes. But this diffusion and electrostatic force goes lower and lower while you have reached into the particles like 1 micron and larger. Another mechanism is not very good at small particle sizes like impaction and interception. They goes all the way up to 0.2, 0.3 micron, then they are become more efficient. But when you combine them together, there is a gap between these two mechanisms, which address our MPPS concern, which is most penetrating particle size, the weakest point for our HEPA filter. This is what the filter manufacturers define in their factory. They are defining this MPPS value and the efficiency of their filters based on this particle size, mostly around 0.2, 0.4 micron particle size. And they are counting all particles in this MPPS ratio to see whether they are capturing as much particles on upstream as possible and then getting less particles on the downstream side. But in order to do this, we are going to see in the next pages, in order to do this, you have to scan the entire area of your HEPA filter. One of the main discussion today, during pandemic, we're discussing about the COVID-19 and the coronavirus. So most of the people believes that HEPA filters are good at 0.3 micron and larger particle sizes. That's not true. This concept is 0.3 micron is the MPPS value, plus minus around this value. So this is the lowest efficiency ratio which the manufacturers are testing their filters. However, if you look at the numbers like the COVID virus, smaller than 0.1 micron, the efficiency goes up to 100%, which means HEPA filter can easily capture coronavirus. Also, coronavirus is not traveling air alone. It always goes with the airborne material, like our salvia. So we can consider having a larger particle sizes, which is fitting into the right side of our spectrum, like 1 micron and larger. Still, we have a pretty good filtration efficiency thanks to impaction and interception methods that our filters using. So for classification, EN 1822, we will come later on under these regulations, but I want to emphasize that all HEPA and HEPA filtration comes with the efficiency and penetration value. Efficiency is what you captured, penetration is what you are sending on the downside of your filter, which is the cleanest part of your area. So this classification, EN 1822 classification, is only valid for manufacturers. So the standard, this regulation itself says it is dealing with the performance testing of efficient particulate air filters, EPA, high efficiency particulate air filters, our HEPA filters, and ultra low penetration air filters at the manufacturer's side. Sometimes filter testing companies, the validation companies, are verifying the EN value of their filters, installed filters, in order to test and scan them. However, you will see under ISO 14644-3 today, we are not testing efficiency of filters. We are testing that the filter already classified as a HEPA in the manufacturing line, but we want to see if the filter maintain the same conditions after we install them in the final location. This is what we are seeing in production areas. As you can see, there are 4 scanning probe connected directly to the particle counters, which is like 0.1 micron as a size, because you want to scan 0.1, 0.15, 0.2, 0.25 in order to see the narrow possible area for your MPPS value. Remember our graph? We have a MPPS value which is in between 0.1 to 0.5 micron. So having a smaller increase between these channels are important. That's why this 8-channel particle counter installed in many filter testing companies set up in order to verify our filtration. As you can see in this report here, this report shows us the area of the entire filter. So the entire filter scans with this scanner, and then this graph shows us the particle, number of particles, and the efficiency value of our filter. So the weakest point, our bottleneck, is our MPPS value for the set. So each filter comes with these stickers on it, showing you the size and class of your HEPA filter. In this case, according to EN 1822, this filter classified as H14 with an efficiency value, MPPS described as 0.18 micron, and the efficiency number, which is the weakest point of this filter, gives 99.999719%. The next one is ISO 29463. As you all know, EN is valid for a European consortium. So ScanAir is writing and managing all EN norms. However, people want to integrate this into the ISO. So everyone worldwide, in the US and in Asia, everywhere, people will follow up the same high efficiency filter testing method for with the scanning technique. So all parts of ISO 29463 is derived from the EN 1822 with extensive changes to meet the request from non-EU members. So this is just giving us the numbers as a comparison table, which is given in ISO standard as well. In table A1, you're going to see it as a classification of filters and side-by-side comparison with EN norm versus ISO norm. EN 29463 is not obsoleting ISO 29463 is not obsoleting EN 1822. However, both of these standard and regulation is valid for today. We have ISO 14690 for air filter for general filtration. This is a ventilation regulation dealing with 0.1, 2.5, and 10 micron particle sizes, which is an evaluation in the lab again, not a site test. We're not making these tests in the filter for the installed filter media. This is just a verification on the production line. And this ISO norm is superseded EN 779. And now, as you can see in the table, there is a coarse definition and PM10, PM1 definition, which is against F, M, and G filtration numbers, which we use for pre-filtration techniques. But this is, again, not a site test. This is a factory or the lab test to verify and certify your pre-filtration mechanism in general ventilation. In the US, there is an ASHRAE 52.2 MERV rating for minimum efficiency reporting value. This regulation describes a method of laboratory testing to ensure the performance of general ventilation air cleaning devices and is not for intended to testing filters in the field according to the document itself. So it gives you MERV rating from 1 to 4, larger for 10 micron, and all the way to 13 to 16, which is between 0.1 to 1 micron. And IST has a lot of recommended practices, which you can find in IST website. Some of them are describing a factory test and lab test for efficiency. Some of them are describing a leak test in a final filtration location. So this is a broad range of regulations written by the IST recommended practices. And as you will see later on, ISO 14644-3 installed filter leakage test is also based on IST recommended practices. Here we came to ISO 14644-3, which is our clean room testing for installed filter tests. Today we are going to cover this part mostly. These tests are performed to confirm that the final high efficiency air filter system is properly installed by verifying the absence of bypass leak in the air filter installation and that the filters are free of defect while traveling from factory to the site. No defect like small holes or any damage in the filter medium frame, seal or leak through the bank framework. So we are verifying this. We are not testing filter efficiency. Standard also described this point. These tests are not used to determine the efficiency of the filter medium. The tests are performed by introducing an aerosol challenge upstream of the filters and scanning downstream of the filters and support frame of sampling in a downstream duct. If you give a summary between efficiency testing and installed filter integrity test, we have test location, which we can define as a factory and laboratory test is for the efficiency testing. But for installed filter, as we described in the name, it should be on-site, a field test for the installed filters. Our aim for efficiency testing is to verify the material, the raw material, as well as after processing it and placing it into the frame, we are verifying that we are still meeting the efficiency criteria as described in EN or ISO regulations. Our aim is to make sure that there is no physical damage, no surface damage, no leakage around the frame, or no bleed through or gasket leak through the HEPA filter after installation. And particle generation for efficiency testing should be around MPPS value, while ISO describes 14644-3 describes 0.3 micron up to 0.7 micron with a geometric standard deviation up to 1.7. And leakage type and reason is the quality efficiency testing due to poor media quality or poor production practices. But on our side is a physical damage or poor installation practice or mechanical damage or logistic issues. So it's completely different side. Now we will start focusing on installed filter integrity testing and our two methods. Before we start integrity testing description, let's talk about installed filter. When we say installed filter, there are different types of installation. One of them, gel seal method, which there is an edge around your frame, puts into the gel seal on your ceiling beam, or vice versa. Some cases, your HEPA filter have these gel seal, and the edge is on the ceiling beam and fits into it. So this gel is not allowing any particles coming through your HEPA filter edge. The second one is above the ceiling. In this case, you are placing all your HEPA filters above your seal from your service area. Your gasket is fitting into this ceiling beam, and many times these gasket leaks are around it. You are able to see all these gasket leaks easily. You have to understand in order to make a proper integrity testing, you have to understand how your filters are installed. Reason I'm saying, if your system is bottom to top installed, you may not be able to reach directly to your gasket leakage. However, between your filters, you are going to see the particles bleeding through. And once you clean them up, maybe the alarm will not sounding through your particle counter or your photometer. But once you wait, again, the particles will build up between your filters. So you will assume that there is a gasket leak around your HEPA filter, a poor installation practice. So understanding how your filters are installed is important. Next one is describing ISO 14644-3. I will not go in detail of every single section because today we are going to focus on installed filter leakage test part, which describes its principle in 427 as to confirm that the final high efficiency air filter system is properly installed by verifying that the absence of bypass leakage in the air filter installation and that the filters are free of defects. And procedure described in Annex B, Section 7, and there are two methods described. One of them is aerosol photometer method, another is a particle counter method. These methods has pros and cons to each other, which I'm going to cover later on. An apparatus that you are using for this technique is aerosol photometers listed in Annex C. Annex C defines all the apparatus that you can use for cleanroom testing. And Section 8 is describing filter tests. And aerosol generators could be pneumatic or thermal aerosol generators or particle counters with an aerosol diluter. And for both methods, you will need aerosol substance. And the standard itself says portions of the test methods given in B7 have been adopted from IEC recommended practices 34.4 HEPA and UPA filter installed filter efficiency testing. Next one, let's start with aerosol photometer method description. As listed in test apparatus part in ISO 14644-3, we have our aerosol photometers with an aerosol generator and suitable aerosol substances, which could be polyalkylene, DOS, DOP, paraffin oil, or mineral oil, depending on your application. But only point that you need to consider here, we will come later on, but the particle size that you are generating should be within a certain size, 0.3 to 0.7, with a standard deviation of 1.7. So that's the only thing that you need to consider, especially when you do the recalibration of your system. You have to check your aerosol generators as well with your aerosol substances. The aerosol photometer method may be used for testing clean rooms and clean zones with all type of air handling systems. It's suitable for all kind of filter installed in your clean room. Installation where outgassing of oil-based volatile test aerosol deposited on the filters and duct is not considered to be detrimental to products and or processes and or personnel within the clean room or clean zone. In some cases, the aerosol photometer method can require a high upstream concentration compared to particle counter method. There are almost 100 up to 1,000 times more aerosol needs to be generated for aerosol photometers. If this is the case, for example, in electronics, the system is quite sensitive for the aerosol mineral oil that you are using for testing of your HEPA filters. In this case, you have to use a particle counter method, which we will describe later on. Aerosol photometers are widely used in industry. However, using them directly through your air handling unit, you have to be careful because while you are testing one of your 100 HEPA filters, the rest of the system will also introduce with these aerosol, also your air ducts. So these aerosols are not volatile, and it's a mineral oil, and this oil will be deposited in your duct and also your filter. So this should be the point that you need to consider. And desirable to choose a probe which has a rectangular inlet. DP is 1 centimeter, WP is 8 centimeter, and you can also use circular probe with a diameter of 3.6. But in general, we are using these rectangular inlet probes in order to scan HEPA filters. This is very good at scanning the corner of your filters and also edge and gasket leakages. Scan velocity is quite critical here, and the standard defined it as a 5 centimeter per second scanning rate. So if you exceed this number, you may skip any leakage, or if you scan slower than this number, maybe particle build-ups will give you a false count, and also you are going to spend a lot of time with a single filter while you are introducing a lot of aerosols on the upstream side. Acceptance criteria defines between 0.1% up to 0.01%, depending on the efficiency of your HEPA filter. But if your integral efficiency is lower than 99.95%, agreement between supplier and customer will be your acceptance criteria. And choosing your upstream aerosol challenge and concentration, as I said before, any kind of material like Laskin nozzle or thermal generator you can use, but make sure you are generating 0.3 to 0.7 micron particle sizes with a geometric standard deviation of up to 1.7. So this has to be verified on regular basis along with your calibration as well, because maybe your aerosol generator or Laskin nozzle generator, thermal generator may have a drift annual basis. So you're not generating a right particle sizes. We'll end up collecting them all in your filter, and the leakage may not be easily detected. In any case, keep in mind, we're not checking the efficiency. For example, if we have a physical damage in your HEPA filter, the size of this damage is like a stadium size. And your particle, if you are sending 0.3 micron particles, they are generally like a soccer ball size. But if you have 0.7 micron size, it will be larger than this. Or if you're sending 0.2 micron, this could be a smaller tennis ball size. But in any case, if your hole is the size of a stadium, then any size of particles will come through these holes, physical damages. We're not making a final filter integrity testing, final filter efficiency testing, but we are testing an integrity. That's why, in any case, we are going to find a solution for your physical damage on your filter surface. And how to test these systems? First of all, you have to measure upstream concentration of your filter, and this will be recorded as 100% as a reference value of your aerosol. If your particles introduced into the system is not homogeneous or changing during your scanning, your 100% may be lower, may be higher. This is one of the downsides for aerosol photometers. That's why end of your testing is described here, you have to verify that your aerosol challenge is still between 85 up to 115% of your first initial recorded reference value. You will scan your filter with 5 centimeters per second and make sure that you're not exceeding this number. And you have to make a overlapping strokes. I have an example later on. I have a graphic which describes how we will do the testing. And these 1 centimeter overlap will be important because maybe your leakage will fit in between your scanning points. That's why overlapping strokes is important. And probe distance from the filter surface shouldn't be less than 3 centimeters, shouldn't be more than 3 centimeters, can be less from the downstream filter face or the filter frame structure, as described in ISO. And this should be performed over the entire downstream filter face for each filter, perimeter of each filter surface, and seal between the filter frame and the grid structure, including all its joints. These are all points that we need to consider. Now we have a question. The concentration of aerosol challenge for the upstream of the filtration, your photometer method, should be between 10 milligram to 1 gram per meter cube, or 1 milligram to 100 milligram meter cube, 10 gram to 100 gram meter cube, 1 gram to 100 gram meter cube. I'll give you a couple of seconds. Okay, our answer here is, it is 1 milligram meter cube up to 100 milligram meter cube. This should be the one that you will be focusing on while you are introducing aerosol challenge to your HEPA filters, while you are using photometer methods. But I want to emphasize one point. Later on, we will cover particle counters. And particle counters are counting real particles. Here we are getting a percentage of upstream aerosol challenge with the photometers. That's why we are using more particles, for photometers, while we are using 1 to 100 up to 1 to 1000 less particles, plus a dilution system with our particle count. Let's start with this technique described in ISO 14644-3. It is an installed filter system leakage test with particle count. Downside of this method, if you are using just a particle counter with a computerized system, you are collecting all this data, and you will see later on there are lots of calculations related to this system. But I will today also introduce you our ScanAir Pro, which makes most of the part of your job by automatic with a smart interface. And each system can use aerosol substances, which is similar with the polyalpha-olefin, or you can use microshares, which we are using for calibration of these particle counters as well, polyester and latex material. And other materials are also eligible for particle counter, because the particle counter is a technology. It can count any particles, any substances, can be used as an aerosol challenge. And we have an aerosol generators specific for this application. You can use the exist ones, but it has to be in a very low concentration. But the small micro and the nano aerosol generators are smaller in size and easy to use with this system. So in general, why this system is quite complex and how we can deal with this part. First of all, while you are introducing an aerosol on your upstream channel, your particle counter counts them after dilution, because each particle counter has a coincidence error ratio, which is 1 million particles per feet cube. So if you exceed this number, this will end up having a coincidence error, and your optic system will be ruined with this mineral oil. It has to be cleaned with the service department. That's why we have a dilution system. Dilution system, when you are using, let's say, 1 to 100 dilution system, 99% of all particles are captured with this diluter, while you are just counting 1%, and your computerized system should multiply this number with 100 in order to define the upstream challenge. This is one layer of information that you need to provide. Another one, scanning downstream side. You have the second particle counter, which you are scanning the surface of your HEPA filter in order to define the leak points. All these raw data connected to your control PC, and after that, you will be making a lot of calculations through these raw data. That's why the standard defined laser scattered airborne particle counter method may be used for testing clean rooms and clean zones with all type of air handling systems. Installations where the outgassing of oil-based volatile aerosol deposited on filters and ducts cannot be tolerated, like in electronic industry, or could be a pharmaceutical application nowadays, or where the use of solid aerosol is recommended. Note to this entry in the standard itself, this method requires a series of calculations. This is the downside to set up the method, and can also require the use of a diluter. The calculations can be manual throughout independent computers, instrument link computers, or any technologies within automated adapted laser scattered airborne particle counter instruments. There is an entry again. This method can also be used with oil-based aerosol where outgassing can be tolerated. And now I'm going to cover with automated adopted laser scattered airborne particle counters with like a ScanAir Pro systems. The reason I'm covering this part is, as you can see the previous slide, we need to make a lot of calculations in order to skip all these parts and cover all these calculations through our device. We are now selecting our product and making filter testing through the ScanAir Pro. Acceptance criteria, again, 0.1% up to 0.01%, depending on MPPS value, as well as if your efficiency is lower than 99.95%, you have to come to conclusion of your acceptance criteria between the customer and the supplier. And the interface of our device gets all this information, and you're just clicking with a one click in your handle. You can move it into upstream and downstream. Remember the graphic I showed you? There were two particle counters. One of them was connected to dilution system. In this case, you don't have to connect them all. You have one particle counter, and the system moves from upstream to downstream by an automatic solenoid valve controlled dilution system. And your alarm settings, which is your efficiency, which is your filter integrity testing level, and the visual indication with a percentage of your scanning rate. You can easily start and stop your sampling through the handle unit. And how to test? Again, from the standard, the concentration of aerosol challenge upstream of filters should be sufficiently high to achieve acceptable practical scan rates. That's important because if you are introducing non-homogeneous or less aerosols into your upstream challenge, then while you're scanning the device, your device may not be scanning the right upstream challenge. That's why ScanAir Pro comes with a smart interface which takes an upstream challenge and tells you if this is insufficient, if you need to increase your upstream challenge through your aerosol generator. It asks you to repeat upstream sample. The second thing here is, in most cases, generated aerosol should be added to the upstream aerosol challenge to reach the necessary high challenge concentration for your filter. If this is the case, your particle counter may be ruined. That's why dilution system should be connected to the device according to ISO. So in this case, we have our dilution system, the smart dilution system, which you can hook up your upstream and downstream together with and just the handy unit describes testing upstream and checking downstream. So you're just selecting it through your handle unit type stream. Next one is the upstream aerosol concentration measurement. Taken immediately upstream of the filters should not vary more than plus minus 15% with the time from the average measured value. So this is another challenge, because if your upstream value changing and you are not constantly sending aerosols into your HEPA filter before you test it, the recorded upstream challenge may not be true. This is the same problem for photometers, and we have the same challenge for particle counter method. That's why ScanAir Pro is now checking all the concentration in your upstream, and if it's not a uniform, then it asks you to repeat upstream sample. So this avoids any error before you start testing your filter. And then we talked about the downside of particle counter method. Standard describes a lot of calculations, which is known as MP and A value, which you collect all these definitions. I will not name them all, because in the new technologies, now we are just entering significantly our scan rate and mode of scanning, and our upstream challenge will be recorded automatically, and this MP value will be calculated by the device itself. So the downside of the system is obtaining this NA and NP values. So the system will calculate it based on the information you gave to the system, and also the information that the system obtained with a smart technique. And this NP value allows you to change your scan rate depending on this NP. So if you have a higher NP value, you can select a speedy scan rate, but we always recommend you to go with 5 centimeters per second, feet per second value. So all these calculations through the application with the rectangular and circular probe given in table D3 and ISO 14644-3. So once you do all these calculations, you are obtaining MP and NA value, which is made by ScanAir Pro in an automatic manner. So the firmware we developed as Lighthouse, making all these jobs, so you don't have to worry about them. So install filter integrity testing with a particle counter. First, measure upstream and record it. Scan your filter with 5 centimeters per second scan rate. Then slightly overlap your strokes, and after approximately 3 centimeters from downstream filter phase or less has to be maintained throughout the filter, by the way. You cannot start slower and go faster after that. So throughout the filter, it's important to maintain the same scan speed and also scanning distance. Repeat upstream measurement between and after tests. So between these tests, sometimes we're seeing that people are introducing upstream aerosol within the room and using the same aerosol challenge in order to test the other room. Even if you are using photometer or particle counter, when you change your location, when you are moving into the other duct, you have to verify your upstream challenge. So that's why you should have a plan of upstream cycle between measurements. And every after test, you have to verify that upstream measurement is between your limits, defined as 15% plus minus your initial upstream record. Here in our device, when you enter the upstream challenge and record it, we have a 10-second moving average. The instrument takes 4 second purge first, then 5 2-second readings, and internally calculates the percentage difference. And if this difference is more than 20%, then your screen says, oops, you have unsufficient, sorry, you have non-uniform upstream challenge. So you have to make it uniform before you start. Then the progress shown through this bar, and it indicates your upstream sampling is completed or not. Let's take a look at it, how we are scanning filter. Unfortunately, I'm not able to do the demo through this webinar, but we developed a small test setup for you here. So you have your scanner. First, the perimeter of each filter, the seal between the filter frame and the grid structure, including its joints, should be scanned. Before you start scanning the filter media, all around your filter, gasket frame, and any potential leakage points has to be scanned. Reason here is After manufacturing and verified with EN or ISO norms at the factory, most of the filters are shipped out with an integrated system. But during logistics, sometimes they are wear and tear around the filter media. So these corners start bleeding through, or the filter frame, if you are not installed it properly, the frame gasket, you start seeing the leakage. That's why we are starting testing all the joints. The second thing here is you have to make a quick face scan to integrity of overall filter and scanning probe verification and checking the significant leak. You don't have to worry about your speed. It's just before start, you're just making a general scanning of your filter face. So to see if there is a high leak. In some cases, you have a very huge leak on the surface of your filter, then you can define it with this. You don't have to worry about scanning it 5 centimeters per second. You already define the leak point. After that, this quick setup, with 5 centimeters per second, you will start scanning your HEPA filter. So after scanning every single side of your filter, you will make with a slightly overlapping strokes. So the stroke within between your area will be scanned twice. Otherwise, maybe within this line, if you move your probe directly into the black location, the black line, dot line, then maybe within this black area, you have a leakage and you will miss it. That's why there will be slightly overlapping strokes. Then after that, when the leak found, a slow to stationary movement to the probe will come through the leakage point, and you have to locate its position. We are recommending you to put these single dots, the labels, the sticky labels, directly onto the filter surface and to the side in order to define cross-section of your leakage. If you prepare all these dots to your hand, like 1, 1, 2, 2, 3, 3, while we are doing scanning, you can just take it, place it into the corners or edge of your filter. So cross-section is this point, will show you the leakage point. So this is in general how we are doing a filter testing. And if you make a side-by-side comparison, like I said, photometers and also particle counters has pros and cons. And you have to define the right method for your application. Photometers require 100 to 1000 times more polyalpha-olefin or any other aerosols as a particle counters compared to it, which means if you are consuming 100 liters of aerosols through photometers, you need 1 liter for the same area of scanning. So it is also depending on the consumable cost. This is also a cost saving using particle counters. Particle counters are using small generators. There's no fire risk. You don't have to worry about sending these aerosols, and you can use a lasting nozzle, the cold generators with particle counters. So this thermal generators has some issues with the fire risk, and you may avoid it. Photometers are good for large system setups. It's easy to set it up and send all the aerosols through the HEPA filters, every single HEPA filters in your facility, but be aware of oil contamination. If you open up your air ducts after a couple of years, just put your hands around it. You're going to find out there's a leakage build-up. There is a particles, the mineral oil build-up around your air duct and upstream side of your HEPA filters. Microspares can be used with particle counters to eliminate polyalpha-olefin in small systems, like in electronics or PTFE media, which is a special technology which allows with the particles, not using mineral oil particles, but only microspares. And polyalpha-olefin may degrade gel seals in filters. What we saw in field, and some of our customers also reported, using an excessive amount of polyalpha-olefin may degrade your gel seals and starts and build up a leakage around the filters. There's a smart technology behind the particle counter method. If you are using a smart devices like ScanAir Pro, you don't have to worry about all these calculations and your testing will go smooth. Your concentration level and homogeneity will be verified and approved with the system itself. And real particle counts will be used with particle counter method instead of using a relative percentage of concentration with the photometers. So you have to understand your system application first, then you will see the positive side of using photometers and the positive side of using particle counters. We as Lighthouse trying to make it as easy as possible with the technologies that we developed in order to skip all these calculations and in order to avoid spending time with the raw data. That's why I try to explain all these differences. That's what I'm going to share with you today. Thank you for listening. Now I will check the questions part. Okay, here, let me see these questions. Okay, the questions section. Okay, the EN norm. Yeah, the EN norm, that's true. One of our attendees is asking, can we use this EN norm in our facility as well to verify our manufacturers? No, you can't, because the EN norm scans, there is a special devices with a smaller particle sizes, like below 0.1 micron. They are testing every single filter area and define an MPPS value. You don't have to worry about. In fact, you can verify your manufacturer whether they are making every single filter test instead of making a batch sampling. They should go with every single filter, and these filters should be sent with an EN report along with devices, and you will be verifying it. Also, as a manufacturer, you can visit your supplier and verify their method and testing their systems. And we set up the number of particles we use for filtering device. Okay, let me make it larger to see better. Okay. Can we set up number of particles before filter for the device if it was measured using different counters? Yes, you can. You can have a different setup connected to the same system, and you can collect both sides, let's say 0.3 micron and larger particle sizes in upstream as well as on your downstream side. So you can align these two data with the time stamp. So you will be seeing the efficiency increase or decrease throughout your filter. Okay, let me open it up a little bit because it's quite narrow. Okay. Can we use the same aerosol generator using aerosol photometer in particle counter methods? If not, do you offer these generators? Okay, you shouldn't use them because the idea behind using particle counter is to introduce less aerosols. Even in the lowest possible adjustment with a photometer aerosol generator, you will have a lot of Laskin nozzles. We have our own aerosol generators, which has a quarter Laskin nozzle, and this Laskin nozzle generates a few aerosols, sometimes even invisible to your eye, but will be enough for our particle counter. So saving up for time as well as saving up for the entire system, we recommend you to go with the micro aerosol generators. Yes, we are offering them too, but you can find them from the field as well. Another one. Is it possible to determine the filter integrity looking at the airflow rate? No, you cannot define it just looking at the airflow rate. Airflow rate is one indication, but integrity of the filter is completely different thing. What I'm trying to say is, maybe your filter has a gasket leakage, but still it is small enough to send particles into your room, but not large enough to have the air pass through this leakage point. So in this case, air velocity profile will be perfect, but you are going to see, still you are going to see the leakages. Thank you for the webinar. Most welcome. Can you explain about relation with the filter HEPA and laminar flow? operation with the HEPA and the laminar flow. Okay, I think the question is about the connection between HEPA and the laminar flow. Laminar flow, first of all, we're not using laminar flow definition anymore. All the ISO standards are now considering unidirectional flow, because laminar flow, you can only generate them in laboratory conditions. You cannot do it on the field. That's why unidirectional flow. Unidirectional means wherever they go, all the particles are waving, all the airstream are waving with the same distance. So if we are taking a look at the HEPA integration, let's say you are a pharma, in grade A, we are checking for unidirectional measurement after checking HEPA filter integrity. But for the rest of area, B, Z, D, and areas, we're not taking care of unidirectional conditions, because most of them are turbulent air conditions. That's why we are testing the HEPA filter integrity with the same way, but we're not checking laminarity or unidirectional conditions. Does testing the integrity for operating theaters in hospital is enough, just to ensure that there are no substantial leak in the filter? If you are making a proper filter integrity, and if you are installing an efficiency tested filters with a proper way, then these filter integrity testing is enough to make sure that there is no leak, because you verify them. But if your filter quality is not good enough, but you are just making an integrity testing, you may have issues in the long run with the filter quality. That's a completely different thing. But if you provide a good EN 1822 certification or equivalent ISO certification from the supplier of your filter, and make it properly installed into the operational theater, then there won't be any issue with the system setup. Okay. Most welcome. I'm seeing a lot of thanks message. Okay, is the printout of the results recommended by ISO 14644-3? In all ISO standards, not only in ISO-3 test methods, having a printout as a proof media is important, like we are doing for the particle counters. So make sure you are following the same path and have the printout from your photometer or particle counter testing system set up, and have these printouts recorded along with your report. Raw data, your final report, and raw data printouts from field are essential in order to prove what you did, because what you are proving what you write. So in order to prove what you write, you have these printouts. Okay, we have a couple of questions more, but we come to conclusion of our webinar. Thank you very much. I'm going to answer all other questions through your emails, don't worry. Thanks for joining us today, and hope to see you in our coming webinars. Take care. Bye-bye.